Is the freezing point of water always the same temperature?
Hello, water enthusiasts and curious minds. Today we're diving into the world of temperature, phase transitions, and one of the most essential substances on Earth, water. Specifically, we're going to address an intriguing question. Is the freezing point of water always the same temperature? Prepare to have your minds chilled with knowledge.
What is the freezing point of water?
To kick things off, let's start with the basics. The freezing point of water is typically understood to be 0 degrees Celsius, or 32 degrees Fahrenheit, under standard atmospheric pressure. This is the point at which water transitions from its liquid phase to its solid phase, known as ice.
Does it always freeze at the same temperature?
Now to our main question. Does water always freeze at 0 degrees Celsius? The simple answer is no. While it's true that pure, distilled water will freeze at 0 degrees Celsius under standard atmospheric pressure, this freezing point can change based on a few factors. Let's explore these. Subsection 2.1. Pressure. Firstly, the pressure surrounding the water can influence its freezing point. For example, at higher pressures, water will freeze at a slightly lower temperature. However, the changes due to pressure are usually very minimal unless we're dealing with extreme pressure differences. Subsection 2.2. Impurities. The second major factor is the presence of impurities or solutes in the water. When substances like salt are dissolved in water, they disrupt the orderly arrangement of water molecules, making it harder for the water to freeze. This is known as freezing point depression. As a result, salt water, for example, has a lower freezing point than pure water.
How do these changes impact our world?
You might be wondering, why does this matter? Well, the influence of pressure and impurities on water's freezing point has a lot of practical applications. For example, this concept is why we spread salt on icy roads in the winter. The salt lowers the freezing point of the water, causing the ice to melt, even if the temperature is below 0 degrees Celsius. Similarly, the different freezing points of water under different pressures influence life at high altitudes and the movements of glaciers. So there you have it. While the textbook freezing point of water is indeed 0 degrees Celsius under standard atmospheric pressure, this can change due to factors like pressure and the presence of impurities. It's just another example of how even the simplest substances in our world can have complex and fascinating properties. We hope you enjoyed this frosty journey into the science of water, and as always, stay curious.